Hi, my name is Luqmaan Salie. I'm a computer science master student at UCT. My supervisor is Professor Josiah Travula, and my topic of research is SDN traffic engineering using segment routing and DNS. So just an introduction. The network performance in African NRENs, they are inflexible, they have low interconnectivity, they are unreliable, they're not robust. The broadband speeds don't reflect the network capabilities, and traffic flow between the NRENs use circuitous routes. So here we see a logical view of SANReN, which shows how the universities connect with each other. So SDN is an approach to network management which separates the control and forwarding planes and uses the controller to carry out forwarding. It can automatically change routes when congestion failures or delays occur. All the routers can be programmed from a single location, and this avoids router misconfigurations. OpenFlow is the protocol that configures the flow tables on all the routers. So the image shows the SDN architecture. We see the application layer, which talks through the northbound interface to the control layer, and this is where the controller will be, and it will talk through the southbound interface using OpenFlow to the infrastructure layer, which is where the routers will be, and it will pass on the path. So segment routing is a source-based tunneling technique that allows hosts to transport packets with a list of segments. Segments can specify a route to traverse or a service for the packet to reach. So segment routing reduces the forwarding rule overhead and improves network flexibility and scalability. So here we see the data flow with segment routing. We can see that at each router a segment is popped off until the packet reaches its destination. So software resolved network is an improvement on SDN. It allows network operators to control the network paths used by applications with specific policies. The applications interact with the DNS resolver to specify path requirements such as delay or bandwidth. The controller and DNS resolver work together to forward packets along the optimal path, and the controller only interacts with edge routers. So the image shows the SRN architecture. So what are we focusing on? Research questions. To what extent can we improve end-to-end performance in SANReN using SDN, SR, and DNS? More specifically, would application level traffic segmentation using SDN, SR, and DNS result in better overall performance? And would an SDN and SR solution result in better resource utilization? So to start off, we conducted some network benchmark tests so that we can compare to our final product, which is the network. So we got the internal and external delay. So these are ping tests that we carried out. We used Persona for the internal test and speed checker for the external test. So we can see here that the speed checker tests are much slower because they are coming from external sources, and yeah. And then we also did page load time tests using Persona and speed checker. We can see again speed checker is performing a bit worse because it's coming from outside SANReN. So we also got some data from SANReN to analyze. And here we can see the kilobytes per second by country, inbound versus outbound. So for the inbound traffic, some of them are a bit faster, but for the outbound traffic they are a bit slower. And you can see there's a very large discrepancy between the speeds of the countries. This is the top 15 most frequent countries that we got the data from in the data, except South Africa. So this graph shows us the frequency and the average megabytes per second by country for only inbound data. We can see that China is the most frequently contacted country, but the speed is very low, and then for the USA it's performing quite well in terms of how frequent it is and how fast it is. The line graph is the frequency, the bar graph is the average megabytes per second. And so for the outbound traffic, we can see again the USA is the most frequently used country, but it's not performing very well. And the UK, the United Kingdom, same story compared to, for example, Botswana or Austria, which is performing very well, although they are less frequently used. So to conclude, software-defined networking and segment routing can improve the network performance. DNS resolver provides additional performance improvements and flexibility. Our main focus is to what extent can we improve end-to-end performance in SANReN using SDN, SR, and DNS. And then our solution, which will be created using a virtual scaled-down version of SANReN, and then we will test our solution against the results that we've got from our tests and from the SANReN data.